Hey, good morning. My name is Kyle Astor. I'm the manufacturing engineering manager at Acutech. I'm a 1999 graduate from Meadville. Then I went to Penn State Barons of plastics engineering. A little different. We're an aerospace company. We don't do plastics. I'm going to talk to you about plastic today. So we're going to talk to you about 3D printing, all the ways we use it, and different things. Throughout the presentation, if you have a question, just raise your hand. And when I pause, I'll answer your questions as we're going. That way we don't have, a bunch of people staring at me after 30 minutes with no questions. So as you think of a question, just raise your hand and I'll get to you. I'm familiar with children. I have 7 children at home right now. Or, I'm sorry, I have 6 children at home right now. My oldest is getting married. Not all of them are mine, but they all live with me. My wife's been fostering teenagers. So, side. Jessica?
Jessica Movia. In 2013, graduated from Penn State.
Like I said, you guys have questions, just raise your hand. Today our topic is 3D printing. Does anyone here have any 3D printers at the school? Okay. And we're going to talk about the different ways we use it. So Jessica and I walked around the shop, we have a bunch of shops, we'll get into it. We walked around our facilities this week and just took pictures of the stuff that we 3D print. She's going to pass around some parts so you can look at, just pass them through the crowd.
This is honestly,
and we'll talk about some of these parts and how we use them and what we printed them for as we go through the slides. So we are a award-winning employee-owned, woman-led aerospace manufacturer providing critical components for the aviation industry. I did not read that. That's from our website. So we've about 450 square feet, about 437 employees right now. We do around $85 million in aerospace components a year. If it flies, we have a part of it. So every time Elon blows up a rocket, there goes 100 of our parts. Just dust. The space station, the space shuttle, which is no longer we don't make any Russian parts or Chinese parts or Indian parts. All of our stuff is either for the United States or Great Britain. We make the Airbus and companies like that. All of our material is sourced in the United States. If it flies, we have a part on it. Can anyone guess how many parts are in one 737 engine? How many components go into one engine? Just take a guess. Yeah, go ahead. 1 million. The next one's 1.1 million parts in one engine. I still can't believe that's how many different parts there are in engines. So we make a lot of them. So we have 275 more CNC machines. Has anyone been to Acutech for a tour? Couple people. I encourage you to ask your teachers. Come do a tour. We can work on paying for the bus and that kind of stuff. Come visit our facility. It's clean. I don't get there real big. It looks like this. Pretty nice. All right, we have 3 facilities. Our first facility is in Sagertown. Right off the exit, you can see 79. This is the Sagertown exit. This is our this is the second location that Acutech started. And then Meadville is our largest one, about 300,000 square feet. And then it doesn't look nice, but this is St. Stephen's, South Carolina. So it's always about 70 degrees down here. So in the summer it's always hot. In the winter when you get out, it's nice 60s. So like I said, we have 3 locations. We started in 1988 with 17 or 16 employees. And now we're over 400 space. Locally owned. My boss is, she's a year younger than me. So it's not too high school. Welcome. Where are you guys from?
Gerard.
Or I guess they go Yappies, buddy. That was the teachers do, or they locked the door? They locked the door, send you to the office. My wife teaches 7th and 8th grade. All right, moving on. We have 3 printers at Acutech. The Stratasys F120, an Ultimaker S5, and the MakerBot Method X. You guys probably have Ultimaker and MakerBots in school, that kind of stuff. Yeah. So, like the Altimakers, I think are 6,000 to 8,000, depending what you get. The maker bought, I think that was 10. And then the Stratasys are like we bought the smaller ones, like 20,000. They're nice. Like, we actually prefer the other two. Expensive one. Okay, so now I'm gonna get a little technical. Has anyone heard of a CMM before? Coordinate measuring machine. So 5-axis thing that comes down, it's got a tip on it and measures parts. So pass this around. This is an example of a plastic fixture with an aerospace part mounted to it. See the metal? Plastic. So to make this plastic fixture out of metal, I'd have to design it, make a print, send it out, get it made. It'd be like $300 or $400. I turned this for like 15, 20. So imagine doing that times 20,000 different parts of it. This, I can pay for all the trade turns. So I'll pass this around. Just fold the plastic part. I mean, metal sharp, even a little edge of it. It's not cutting out like. So this is CMM. You can see on the wall. If you flip that over, it's got magnets in it. They actually just put the fixtures on the wall, so they're ready to run. Those are a bunch of fixtures next to it, CMM, just hanging out on the wall. They're all marked, and that's one way we use 3D printing. We'll show you a couple more examples. Again, here's the fixture down here. It's kind of a V-block fixture. It holds the part with a little arm that comes out, holds it down. And that's for inspection. Same thing over here. You can see the tip of the CMM. There's a little ball on the end of it. Hard to see the ball, but there's a red ruby tip on it. It's on the end. That's what contacts the part. So you can imagine we have to inspect every part that we make. Next one is part marking. So almost every aerospace part that gets made gets marked with the part number, maybe a serial number. If something blows up and it's not supposed to blow up, if you see a plane crash or something, they know where the parts came from, and if they can trace it back to your part. We've never caused an airplane crash or helicopter crash. We have blown up a lot of buildings with our bombs that we make, but it's a different topic. You guys saw the bomb outside? Big missile? Yeah, we make, well, we used to make a bunch of those components. Like $3 million worth of month. One of the bombs. And again, this is just part marking. We're holding the part in a fixture. That's a rod end. So that part there, you can see it's, if you come over to the booth, I have one. If you don't make the flaps open on airplane or make the wings or the tail or whatever. A lot of times they don't, they tell you what it goes into now. Another is a laser marking fixture here. So we 3D printed this fixture. You can see the part that's in it is down here. And then it gets a laser. It's hard to see, just a little red laser on top there. Marks the top of the part with the part stuff. So you can imagine making all these fixtures and all these work holdings out of metal, get them machined. Now we just 3D print them. Any questions yet? Any questions about the parts you guys have? Who's got the potty seat? There's the part that looks like a potty seat. Who has it? No? Yeah, there it is. Hold it up. Yeah. It has a hinge on it. It kind of looks like a toilet seat, so that's what they call it. I believe Lord named it that. I don't think we named it that. So you can go ask their engineers why they named it. We'll get into that part in a second.
How much do you think you saved by having the plastic 3D added printing versus when you had to use metal?
So when we bought our first printer were you here? You were intern, 2016? 2015, 2016, we bought a Mark Forge. I don't know if you heard of that one. And it's now they're expensive. We bought it cheap. It's like $4,000. I say cheap. I mean, stuff we buy. Or is cheap.
Yeah.
Anyways, I think it took me 5 to 6 weeks to pay it off. Like I just wrote down the ROI, the return on investment. It was like 6 weeks because just 40 fixtures, at 500 a piece, and we went through, $100 of plastic or something.
Yeah, just a huge difference.
Yeah, I have a, on my computer, I have a spreadsheet. I don't do it anymore because we just know, we know what we're gonna.
Just making sense.
Yeah, I mean, you're printing stuff. And plus you get it in a day. That's the best thing. If it doesn't work, throw it in the garbage, it's printed up. Different. That doesn't happen a lot.
Yeah.
They're usually right the first one. So these are some examples of parts that we machine, but we make them out of plastic first. So we'll hand them to the sales team. Hey, this is what you're quoting. You try to get, make it right. You want, make that part for $30. And it's 3,000. So, this is a large part. There's no scale there. I'm sorry. It's like this big. So we printed it like 4 or 5 different pieces. It's an engine mount for helicopter. Something Lord makes. Some of the parts here we'll print in 2 pieces, so you can see the inside, so you know what you're getting into. So these are just parts that we're printing to get an idea of what they look like. Here, give me your hand. I need some of the parts that I passed out. Where are they all at? This one's made out of titanium. Obviously, not yes. This is made out of gasket. Gasket. So this is 30 I 3D printed the gasket and then set it up in the machine shop. They're hard machines. So you cut it like they were going to cut metal, but they're cutting plastic. What happens is you guys don't know. You do that program and you hit the part. You're not scrapping the $2,000 piece of titanium gasket. You're scrapping the part. This is probably $80 worth of us. It's solid. We have a picture. I think this one, we did it with a bunch of different colors. As it's full run out, it's really long. This goes on the top of that helicopter mount that side. I don't know if this part's on it or not. It may be upper level of something. We make most of the parts that are in the part of the helicopter mount outside. Go check it out. Yeah, it's really cool. So that's the other way. We'll 3D print the castings and stuff beforehand. Test out the tooling, make sure everything's good, make sure you don't run into the expensive thing. And it hurts the machine too. You run into plastic, you're not gonna hurt the machine. So. Let's take it one time. All right, so Accutech Precision Aerospace. So 95% of the parts we make are aerospace. This is an example of a part that's not aerospace. So you can see the part on the left, you can see is the black plastic is a prototype that we printed of the part we're machining. This is a weld fixture. So we're welding 3 components together. You can see on the right is the metal part. There's the metal, there's a piece here, there's weld around here. And then it gets sent out and gets brazed, which is another welding process. Then it comes back and we test it for 8 minutes under pressure. It has to hold like 120 psi or let's say hydraulic pressure. Anyways, for 8 minutes. Does anyone know why it needs to last for 8 minutes? I'll give you a hint. It goes on a torpedo that comes out of a submarine. Because it's going to blow up in less than 8 minutes. So as long as our part lasts 8 minutes, we're good. So that's the longest, I guess, this particular torpedo goes. Part turns into shrapnel. So torpedo part, I'm not sure what it does other than blow up in less than 8 minutes. Kind of neat, but we built the, we 3D printed the plastic here to test out the fixture to make sure it was correct. And mainly because it was a 19-year-old intern this summer that did it. So we gave him this project. He had a lot of fun with it. So he got the 3D print. So another point in Accutech, we do about 35 interns a year, 16 and up, and all across the company. So there's all kinds of interns, be a finance intern or HR intern. Almost every department has interns. So you can apply online. So now I'm going to talk about some robotics. So about a year or 2 years ago, we started getting into robotics. Hard to find employees, hard to find people who want to come to work. The robots come to work every day. So we found jobs that no one wanted to do, stuff that was boring. Like we had a guy that was running probably this job here, probably reading a magazine or reading a book half the time while the machine was running. So we designed, fixturing. This is all 3D plastic printed fixturing. You can see here, and then the robot picks the part up, puts it in the machine, gets the machine, pulls it out. There's another machine I didn't take a picture of on the other side. Puts it in there, finishes the machine, and you put it down. And it's an energy component we make all day, every day. So it's one of the things. So these plastic nesting fixtures are all 3D printing. End of arm tooling is 3D printing. Or 3D printed, there's all kinds of stuff. Some more robotics. Side of a machine, there's a robot that you can't see up here. Puts the part here. He comes out. You can see it's in a 3D printed block. This robot here is on the track. It runs 4 machines at a time. And it pulls that part, puts it in one of these 3D plastic printed sleeves. After it gets measured in the CMM over there in those V blocks. But go in, guys. Where are you guys from? Gerard. Okay, I have to single you out because you're late. It's okay. Have a seat.
Okay.
All right. So yeah, so that's some of the stuff we do with robots. Like I said, about a year and a half, 2 years ago, we got into robots. I think we have like 10 now. Within the last 6 months, our robotics is pretty cool. So if you guys get a chance to come in and see us, tell your teachers you want scores. And I believe we can also pay for busing. Find someone to pay for busing. There's lots of grants out there. Another one of our robots. This is the CMM I was talking about, coordinate measuring machine with the tip on the end here. So this robot takes fixtures out of these 2 racks on each side. You can see the fixtures here on the tray and puts it on the CMM and they get measured. So the guys, when they're machining stuff during the day, they bring it over, stick it in the fixture, and walk away. And the robot knows when something's there, comes and grabs it, and then measures it. So there's not someone sitting there watching this CMM program go for like an hour on someone. How big the part is. You can see the part's loaded here on a fixture, and then here's the fixture. Another one empty, same fixture, just waiting for the next part. So operator efficiency, we found some of our interns over the summers will do like they'll sit there and watch the operator what he does all day. Is he walking around? Is he going over here to get something? So what we do is we'll design little trays and holders with magnets that'll hold different tools and parts. Here's an air gun. So we 3D printed a little holder it's right next to the door. So when he opens the door, he doesn't have to reach down. It's right there. So kind of like a NASCAR pit crew, but not that efficient. We're getting there. Stuff just to hold the parts while they're maybe deburring them or something, just to keep them from coming in contact with each other. So our parts, when they're done, we call it, they're like jewelry. They're clean, no nicks, there's no dings. Because they're aerospace, they'll get rejected. This is kind of hard to explain. Does anyone know what a Johansson block is? Has anyone seen a ceramic gauge block? No? Someone saying you're shaking your head. Your dad a machinist or?
I'm a machine.
You're a machine? Oh, yeah, we're at.
Working small town.
Okay, so you know what a Joe block, they call them Joe blocks? Yeah, it's a nickname. Johansson is the guy that invented them. Swedish somewhere. Anyways, these are gauge blocks. It's kind of hard to see. It's a stack of different thicknesses, so they're an exact measurement. And what they're doing is we're trying to, we put a gauge in between here and here that measures the diameter on a part. So this is the thing that calibrates the gauge. It's a gauge calibration device. Anyways, the girls were having trouble getting the wing nuts off. Someone will crank it down real tight and they can't get the wing nuts off. So we made a little wing nut removal tool. Sounds dumb. They use them all day, every day. So it's one of the most used 3D printed fixtures or devices at Accutech. And you're looking at like $1.50 worth of plastic. But they stick that in there on the wing nut, and now they can do it. So, and I said girls, some guys too. The majority of our gauge lab is on programs. Any questions about that? Yeah, go ahead.
When you guys create something like that, do you sell it to other companies or get copyright or anything?
Not yet. I mean, patents are like 1,000 a piece, I think.
So for $1.50 part, maybe not worth it.
Yeah, I'm not sure. No. Like to. I mean, A lot of the stuff that we use in tool and die in Meadville, in Erie, was designed here. A lot of it from talent and stuff, out of necessity, so, you know, they have patents and stuff on different measuring devices. So, no, not yet, but maybe that'll be a good summer internship project. Always looking for projects for our interns, so Jess always gets her own intern. This is a crane hoist. So kind of looks simple. It's just a piece of plastic, solid plastic. These pull up airplane. It's what the tire goes on, basically, the brakes. It's a big part, and they just lift them up to put them in a box when they're done. But they're all machined, they're all shiny, they're painted, they're inserts coated. They can't rough them up, so they use this piece of plastic. And again, the girls aren't strong enough. I probably couldn't pick them out, they're heavy, and stick them in a box without breaking them. So we make just the ends, different shapes, different sizes, just stuff like that. To aid in the manufacturing. Has anyone heard of spray foam for your windows? You get a can of urethane. Yeah, you girls back there. Yep. So this is basically a big spray foam gun. There's two different chemicals, two different tubes. Comes together, a bunch of heat. The foam gets hard. So we make molds for that. So we 3D print these little inserts. They put a piece of plastic down. You see here in gray. This is a different one, but and then we mold it's basically we're making packaging for our parts. So our part will fit in here. This one, the part looks like this. It fits in and then for shipping. So we don't, take a $2,000 part and scrap it because UPS, FedEx, or whatever the freight is decided to drop the package. So you can see down here, this one's made out of wood. That's what they did back in the day. They carved everything out of wood. When I say back in the day, 5 years ago. We got our 3D printers, now we 3D print everything. It's a lot of reusable packaging. Saves a lot of money. You can see these are the sides of machines. They have fans on them. We put filters on them just because it is a little oily sometimes in the shop. And then they replace it keeps the electronics inside from getting grease and oil on them. So we 3D printed all these housings. You can see they go over top where the fan housings were on these machines. So we bought a $1 million machine that doesn't have filter on the things. I don't know why, but yeah. So you know what coolant is? Pointing at the kid in the black hoodie. Machine coolant in the CNC machine. Does anyone else know what machine coolant is? Or have an idea what's it sound like there? So it's the fluid that comes out by the end mill when it's machining, takes the chips away, keeps the part from heating up. So this is the filter for the machine coolant. I don't know if they couldn't get the wrenches one time. They couldn't find them, but I think they're like a $50 wrench, $60 wrench, which is just, they're plastic. So we just 3D print them. All our maintenance guys 3D print them. They replace these filters. So, just like maintenance on a car, we have our machines are maintained through a schedule. So we make those. This workplace organization, who had the Ultimaker? Anyone? Ultimaker. So you can see the nozzles here from the Ultimaker. I mean, this little stand holds all the different size nozzles. The little disc for the material, the RFID to read it. The scraper, the little oil thing that came with it, that kind of stuff. So it's just a nice organizational tool. So we do stuff like that. These are probe tools in the gauge lab or in inspection. Anyone know what these are? What do they look like? Razor blades. So in one of our inspection processes, we cut like a putty real thin. It's at a bunch of our workstations. So we just had razor blades laying around, which is a good thing. So Jess designed that. So it's a little holder just for the razor blade, just so people aren't getting cut. So workman's comp, savers, stuff like that. These are carbide end mills. So we make so many parts, so many different parts that we can't purchase end mills from company suppliers when we need to. So we actually we have a tool grind department where we grind carbide blanks into end mills. So we made a little stand to hold those end mills. This is one of the grinding wheels. This is the stone right here. You see a bunch of them in this drawer. Each one of these is like $5,000. So we 3D printed little holders that go in the drawers. So when they open up the drawer, they don't knock the stone chip. So grinding stones like a compressed stone. That's this right here. So it goes into our machines and then they make these in the mills. Different results and stuff.